Good evening, guys. Can you hear me? Today we have lots of different topics. Very interesting problems are there. Very good. It was- So today we have topics on one is on polynomials. Let me check. There is from probability theory. There is from geometry. And there is from combinatorics. Hi, Debargo. So we have interesting problems today. Very interesting problems. So let's check. Let's try to enjoy them together. By the way, Shubha Vijaya to all of you. Yeah, I'm speaking. All of you can hear me, I guess. And happy Dasera to all of you. After a long break. So don't think about from which exams. Okay, you want Geo? Sure, we will do Geo. Sure. Hi Esther, how are you? Okay, so let's start. Let's start with the problems. The first problem, as Raghav has asked for, let's type the problem. Let's give the problem over here. It's a really interesting problem. All of you can see the board, I guess. All of you can see the problem, guys. Very good. So let's start and discuss together, okay? So if circular arcs, okay, so the circular arcs means a part of circles, have centers AC and BC at B and A respectively. Okay, 1 second, just 1 second, give me a moment. One second, guys. Forgot to give a link to somewhere. Okay, so there are lots of circles. It's really good. It's really good. So essentially, suppose there are circular arcs AC and BC, which have centers at B and A respectively. Then there exists a circle. Okay, A and B are joined. There exists a circle to both AC and BC, the arcs, and which is tangent to both AC and BC and the AB line. Okay, as shown in the picture. And the length of BC is 12. What is the circumference of this circle? That's a beautiful question, okay? So think about it for a minute, then let's do it. Okay, so let's start. Okay, so we have two circles, circular arcs, AC and BC. Okay, AC is also 12. Why do you think so? Why do you think so? Who told that they are not same or equal or not? Common radius of AB. Okay, perfect. So that's first. That's the first idea, guys. So it's told that AC and BC have centers A and B. Okay, and they have common radius, that is AB. Perfect. That's a very good observation. Whoever stole it. Uh, but it centers A and B. Okay. So suppose for C, its center is A, and AB is transcended to C. That is AB must be equal to AC. Okay. So this is the idea. AB must be equal to AC, and similarly, AB must be equal to BC. Right? This must be equal to this. So this is an equilateral triangle, right? So it's a 60-degree angle over here. This is the first observation. All of you understood this? ABC is perfect. ABC is an equilateral triangle. To all always correct. Perfect. Totally correct, guys. What happened to my handwriting? So we are so read the problem, Kanishk, and then you can understand what we are sort of doing. Okay, ABC is equilateral. We have proved it first, just from the given information. What's next? What's next? So essentially, the length of BC is given to be 12. So length of not the arc BC, but this length BC. So it's all of them are 12. Okay, I think this was not 12. This was 12. Okay, then what is the circumference of this circle? Can someone tell me now? How do you do the next step? Arc. I don't think arc length has 12 length. I think BC means the length of. Yeah. So let's try to understand this now. So how will you understand this totally? About the radius, can someone tell me? How do you get to know about the radius now? Tell me about the idea, guys. Okay, that's quite plausible. That's quite plausible. But tell me an algorithm, how will you construct it? So this is the idea. This is a diagram actually. Here is the circle, small circle out here. So you need to find the area of the radius of the circle. You need to draw the tangents, okay? Then, so they gave me an answer. I don't know how did you get it. The radius of a larger circle is 72 by pi. Okay, why is this true? So tell me, how are you getting this? Tell me how you're getting this. Oh, ABC is okay. It's really easy. See, observe Olivia. This circular length, this green circular length arc has center at A, right? Therefore, AC must be equal to AB. And this circular arc has center at B, and BA must be equal to BC. So therefore, AC is equal to BC is equal to AB. Therefore, it's equal to 12. All of them are equal to 12. Okay, let me check the question once, whether it's actually the arc length or the length of. In any case, we can find the arc length, right? If this is the arc length, if this is the radius is 12, right? Therefore, you can find the arc length too. That's not a very big deal. So you can assume we're continuing with this BC. It's a one-on-one function. So if you know the radius and you know angle, therefore you know the arc length. I hope you understood, Olivia. So now observe that, guys, that therefore how do you find this radius? Tell me. This is the radius length. So how do you find the radius now? It doesn't seem really hard. Okay, center of the circle O. Then can you prove the circle O is actually the circumcenter or the center of this equilateral triangle? Can you prove that? Can you prove that, guys? This center O is actually the center of this equilateral triangle. Connect O to AB. Yeah, I have drawn a perpendicular. Yeah, that's what I'm asking you to prove. First of all, this point, this is from the symmetry we are sort of arguing, but we can also prove it rigorously. First of all, observe this very carefully. What is essentially the diagram? Diagram looks like this. And I need to draw another one. Oops, not like this. Let me sort of adjust it. Give me a minute. It's sort of like this. Okay. And sort of you're connecting this. Very bad with circles I am. Yes, I hope this makes sense. Yeah, whatever it is. So here is the center of this. Here is this, here is this. So we have drawn this AB and this is C, okay? And we have drawn this circle over here. Okay, this is center, okay? So if you're drawing a perpendicular here, we are going to show that this is actually the I mean, it actually passes through the center of this. Actually, this passes through this. Can someone tell me why? Why this is true? Can someone tell me? Can someone tell me why this passes the center? This perpendicular, this line joining. Center of the circle. You can understand the symmetry of the circle, right? You can easily understand the symmetry of the circle. That it must pass through the center. Because the circle is symmetric, right? The circle, this line must pass through the center, right? Can someone prove to me theoretically, like mathematically, why this is true? Can someone tell me why this must pass to the center? Simple. See, the tangent line joining the center, this lie on a straight line. You must be knowing this, right? This line must on a line on a straight line. Similarly, these two must lie on a straight line. The point of tangents, the center. Okay, and therefore, what else? Therefore, this must also. So therefore, what's next? Theoretically, in the sense that this one. I mean, I'm asking you to prove like with some results you know. Otherwise, it will become boring. Not boring in the sense. I mean, like not fully proved. Yeah, we can construct those. Then what will happen? You're on the right track. We can construct at those points. So I'm asking you to prove that the perpendicular, this line joining this will be perpendicular to this. Now this passes to the center of this circle. Why this is true? Think about this, okay? Think about this. Otherwise, I mean, I don't want to drag it too much. Anyways, so if it's true, so I assume it's true, okay? Think about it. It's a problem. So suppose it's true. So therefore, what will happen? Therefore, the line passing through this passes through the center, right? You can sort of understand from the symmetry to it passes to the center. It's really easy to, okay? So you can prove it. You must prove it rather. So if that passes to the center, therefore what happens? Therefore, this is a perpendicular bisector of this. Then what can be done from this? You can also prove it that this is sort of perpendicular to this line. Okay, that is this. So it's essentially a circumcent, the centroid. Also understanding this, what I'm trying to discuss now, guys. Any doubts? So I'm trying to prove that O is the circumcenter of this triangle ABC. O is actually the center since it's an equilateral triangle. If it's the center, then we can find the circumference of we can find the radius, right? Because we know the length. All of you understood this? Congruence is a good way. All of you understanding the theory, guys? Good. I'm not shouting, Shikhar. I mean, you can lower your volume if you want. Good. So, therefore, now if that is the center, what will happen? This is 12. This is 12. The length is 12. So, therefore, it just take the you just take the what is the length of it? It's root 3 a by 2 for a equilateral triangle. The height, that is 6 root 3, right? And with the 6 root 3, the centroid divides the ratio in 2:1, right? 2:1. So it will be 1/3 of it. That is 2 root 3 the area, this length. The radius is 2 root 3. The radius is 2 root 3. The circumference will be 2 pi r. This is 4 pi root 3. Okay, very easy stuff, guys. Someone told this answer before? Also understood this, guys? Any doubts? But this proof is not complete unless you prove that it's actually the centroid. It's your duty to prove that it's actually the centroid. We can understand from the symmetry actually, but it's your duty to prove also it's actually the centroid. Okay, guys? It's actually the centroid. Yep. So may I move on to the next problem? Very good. Sorry, but can you prove me why it's a centroid? Yeah, you have to calculate that in some exams. Okay. First is this. We have proved that ABC is an equilateral triangle. Second, we have proved that O is a centroid of this triangle. If O is the centroid of this triangle, or the center of this triangle, the height is root 3 a by 2 if the side length is a, right? And the centroid divides in 2:1 ratio. Therefore, it's 1 by 3 root 3 a by 2. That is a by 2 root 3. Okay, and a is 12 over here. So therefore, you got the radius over here. Right, Dattatreya? Yeah, but orthocenter is the centroid, you're right. But how can we know it's the orthocenter over here? That's also a question. So you have to somehow prove. So that's the idea. The proof is not really hard, okay? Yeah, congruence of ACD. Okay, that's a good observation. ACD. What is D? No. First is CCC. The idea is that okay, ACD and the congruence of AOD. No, what I'm trying to prove is that C, the perpendicular from C to AB, okay, is passed through the center of AB. That's true. You have to prove that it passes through O actually. The perpendicular from okay. The perpendicular from C to AB actually it passes through O. That's my point. That you have to prove. That's what you have to prove, okay? Anyways, so think about this. You have to prove that. So the remaining part of the proof remains that perpendicular from C to AB passes through O. Okay, and this is the first part. And the second part is that okay, and the second part is that O is the centroid. Okay, this is the first part, and the second part is this. Or you can prove circumcenter, whatever you want. Okay, orthocenter, whatever you want. How did you get Kanish? Can you tell me? Okay, you tell me after. Perfect. Very good, Kartikeya. Very good. So that's what I wanted. Yes, you're right. So perpendicular from some C to AB passes the center of AB. Perpendicular from O to AB passes the center of AB. Right? Therefore, they must be collinear. So good. Very good. Nice one. Karthik, I wanted this subtle logic actually from you only. Very good. So now you have to prove that O is a circumcenter. Okay? Now you have to prove that O is a circumcenter. And it's not really hard. You can easily prove that, I guess. You can easily prove that, I guess. Yes. You can prove that by angles, maybe. Okay, you tell me after the class in Skype, okay? In the Cheenta group. I will reply to you. Or you can tell me in WhatsApp if you have my number. Okay, so let's move on to a different problem now. Let's move on to another problem. I really like this problem because it's a bit interesting one. I love this problem rather. Okay. So I will show a graph. The graph below is the following. So I will show a graph now. Okay. Now I will show you some numbers. You have to tell me that which is the following, which quantities are the following. Some quantities out of these quantities, which is the smallest. Okay, that you have to tell me. All of you got a question, guys? Quartic means degree 4. You're right. The graph below is a quartic. You're right. Now, which of the following is true? Think about it, guys. Think about it. Biquadratic is quadratic. You're right. Okay. So the graph is, this is a 4-degree graph, 4-degree equation graph, polynomial graph, and you have to find that which are the four quantities of the list. For this, you need to know about Veda's formula and stuff like this. Okay. P of -1 equal to 4. Why is it 4? Tell me. Why is P of -1 4? I don't think P of -1 is 4. P of -1 is less than 0. Quadratic is, oh, P of 1. P of 1, yeah. P of 1 is A plus B plus C plus D. Oh, I'm so sorry. Oh yeah, P of -1 may be 4. I'm so sorry. What I'm seeing actually, yeah, it may be 4. Can you do it in a different manner? That's my question. Without seeing from the graph. Anyways, even if you know the stuff, how will you know that which is the smallest? That's my question. You have to obviously use the graph. The graph is therefore given. It's just Veda's formula, guys. It's really easy. You're almost correct. What is this? So, see, try to do like this. Find S for some Z for this. Find some A for this. Not for A. Find some alpha for this is this. Find some, this is equal to some P of alpha. This is equal to P of beta. This is equal to P of gamma. This is equal to P of xi. Okay. What will be the alpha? Product of the zeros. Do you know what is the product of the zeros? So try to understand this stuff with respect to some value of that, okay? Some value of some P. Can someone tell me what is the product of 0 in terms of P of alpha? What is it alpha? D, right? Yeah, perfect. So product of the roots is D. This D is the product of the roots by Veda's formula. So therefore, this is equal to P of 0. D is equal to P of 0. Perfect. You can understand that P of 0 is greater than P of -1. So therefore, this option is cut out. This cannot be the smallest. Now let's do product of the sum of the coefficients of P. What is the sum of the coefficients of P? It's P of 1, right? Now P of 1 is less than P of -1. So therefore P of -1 cancels. This remains the smallest now. Okay. And some of the real roots of 0 of P. Can someone tell me what is the real, some of the real roots of P? How we can find it? So we have to find the product of the non-zero real roots. Okay. Some of the coefficients of P and some of the real zeros of P. All this stuff you have to find out now in terms of the P values. How can you find it out? That's the question. Sure. So P0, okay. So if you do x minus alpha, so not say alpha, let's say R1, R2 are roots. is equal to that equation, okay? Now if you put x is equal to 0, you get d, right? On 1 of p of 0 is equal to 0, is equal to d, and you put x is equal to 0, what do you get? Is equal to r1, r2, r2, r3, r4, right? It's a product of the roots. That's what I'm telling. It's a product of the roots. Yeah, p of 1 is the sum of the coefficients, you're right. But we cannot really, so that's why we told that p of 1 is smaller than p of minus 1. Vieta's formula connects the coefficients. So Vieta's formula tells that the following. X minus alpha, or let's say R1. It can be done for any polynomials, okay? If you expand this now as 6 to the power 4 plus ax cube plus bx square plus c x to the power 4 plus d, then a can be written as the summation of ri minus of summation of ri. B can be written as summation of ri rj, the roots. C can be written as minus summation of ri rj rk. Okay, taking 3 roots at a time. And D is equal to r1, r2, r3, r4, the product of the roots. Okay, you can search of Vieta's formula and read about it. Essentially, it connects the roots and the. No, it's nothing is given which is positive, which is negative. You have to understand from here which is positive, which is negative. Diagram is given, and the diagram is given. Most of the things can be understood. So we are left with product of non-zero real roots, the sum of the coefficients of p, and the sum of the real zeros of p. Can someone find it? Which one will I tell, Raghav? Perfect, Rajvardhan. So we have 2 real roots and 2 non-real roots. Perfect. So 2 real roots and 2 non-real roots. How can you find the non-real roots product? Very good, Rajvardhan. I really like it. So product of non-zero. So observe the product of the real roots. The real roots are greater than 1, right? The real roots are greater than 1. And the product of the real roots is what? Product is what? Product is not only greater than 1, but 1 and greater than 3, okay? So product of real roots is greater than 3. Okay? And product of roots क्या है? Product of roots, all the roots, is what? Is P of 0. P of 0 is what? Or greater than 5 almost. Less than 6, say. Therefore, this implies that product of non-real roots is what? Is less than 2. You can prove it. Which is less than P of 1. P of 1 is greater than 2. So therefore, this also cancels. All of you understood this really beautiful idea? Product of real roots actually greater than 5? No, greater than 3 and greater than 1. See, we don't know the numbers, okay? We can actually tell something about it. But yeah, we got the idea, right? This is a really beautiful problem. I like this problem a lot. Like, I really like this problem. All of you understood that P1 is greater than this one? All of you understood this? P1 is, oh, I'm so sorry. P1 is less than this, no? Oh, this asks for the smallest. So sorry, I'm so sorry. This should not be this. So therefore, P1 gets cancelled because it's less than P1. We need to find the smallest, right? Why do you tell greater than 5? I don't understand. Since you're telling is greater than 1.5 or greater than 3.5, that's why. We will do this. We will do this in more details. Like in more details means in much more clarity. We will go into much more details. Okay, more calculations only if we need to compare. We can't compare at a very like higher level, macroscopic level. Now, what is the sum of the real roots? Can someone tell me what is the sum of the real roots? How do you find it? Sum of the real roots? Whether it's positive or negative. Sum of the real roots is what? It's really easy. It's greater than 5. It's greater than 4, right? 1 and 3. Right? Which is less. So therefore, it is also greater than this product of the real non-zero real roots. Therefore, C is the smallest. We are trying to find the minimum. P0 is greater than 5? Yeah, P0 is greater than 5. Oh, no. See, product of all the roots is less than 6, right? And product of all real roots is greater than 3. Therefore, product of all non-real roots must be less than 2, right? Try to understand this very carefully. So this problems. So I feel like Sherlock now. I really love this problem. All of you understood? Okay, this it's me in XG coder. Who is this or whoever is this? Please tell me where you didn't understand. I love this problem. Okay, so let's move on to the next problem unless people have some doubts. So I will move on to a different problem. Let's see. Okay, which class you're in? Like who didn't understand anything? Olivia, are you understanding? Okay, so we have two problems left. One is probability, one is combinatorics. Which one do you want to find? Do guys. I forgot. Okay, please try to understand, Olivia. Let me know where you didn't understand in my WhatsApp. Okay. I don't know. I forgot the source. Okay, combinatorics. People. Okay, let's do combinatorics now. Um, combinatorics problem. Okay, there's a problem over here since it's a double page problem. Okay. No, I got that. I got it. Okay, fine. Eight congruent equilateral triangles. All of you know regular octagon. Do you know octagon? Octahedron, sorry. It's a hard problem. As far as I remember, it's either from AIME or AMC, somewhere from there. Those problems are really good. Of PRMO level, you can. So, Sujil, the only way to prepare for PRMO is to solve problems. It's like asking how to not stay hungry. Just the only way to not stay hungry is to eat food. Are you a student of Cheenta? Then try to solve easy problems. Okay, so let's focus on this problem, guys. How many eight congruent equilateral triangles, these of different color, used to consider regular octahedron? Okay, I'm giving you a diagram of regular octahedron. Octahedron regular. Let's see if I can get a diagram. Yeah, I got a very good diagram, very beautiful diagram. I'm sure you will love it. It's an octahedron. If you open up the octahedron, you will get this. Okay? If you open up the octahedron, you will get this. The previous question, this was the previous question, Raghav. Please take it quickly. I have to move on to the next problem, Raghav. You're totally right. Tetrahedron with the same base. Now this interface is very good. This Jam wala interface, Google Jam. Okay, so let's do it. Say congruent triangles, each of a different color, used to construct a regular octahedron. How many distinguishable ways are there to construct an octahedron? Yes, you're right. The seminar will be till 8 p.m. Yeah. So now we need to understand the rotation fact, right? So therefore there is an extra addition. So let's try to understand this. Two octahedrons are same if neither can be rotated to look just like the other. Okay, that means the rotational symmetries will not be taken care of. I forgot. Yes, Shavani Chakraborty. I mean, yeah, forgot your name. So yeah, so essentially, yeah, you're right. So essentially, how will we Do this. Now, it's not 8 factorial. The idea is that you have to rotate it, okay? The rotation, suppose you color it, just like you color it same, okay? Just rotate the colors. How do you do it? That's the idea. Suppose you rotate the colors, how do you do it? The answer is less than 8 factorial, you're right. Okay, so Kanishk is asking that we fix one colors and then then color the rest. How do you do it then? Think about it. There's time, don't worry. Think about it, but think about it. How do you manage the rotations then? Yeah, Aniruddha, I remember now. Yes. You're right, Jyoti, actually. I am receiving these lets. Okay, so think about it. How will you approach this problem? So there are 8 congruent diagonal triangles, each of different color. Okay, to consider a regular octahedron, how many distinguishable ways are there? So to avoid the rotations, remember about the rotations. That's it. So think about it. 7 factorial? No. Okay, so Kanishka is asking us to fix one face color. A 7 factorial is not the thing. But if you fix it, then what will happen? If you fix one face color, then what will happen? See, fixing one face color is not the way out because it can be different colors, right? Also, right? So how do you do it? Or yeah, fixing one face color is maybe it's correct. Let me think. Yeah, it's a good option. Fixing one face color is a good option. Yeah. Fix 2 face colors. That's even a good option. Okay. Okay. Nice ideas. Go ahead. You're on the right track. So fixing one is a very good option. So okay, let's take this as a hint. So fix one face color. Perfect. So fix one face color. Fix one face color. But why is that? Is that not like that? Not the final solution? Can someone tell me? After fixing, it will not really have a final solution. Fix one face color. So essentially, you have to find the rotational symmetries. That's it. Nothing else. Fix one face color. That's the first step, but that will not be fine. Suppose you fix this face color as blue. Okay. Why this is not true? Why this is not a viable, like why this is not really a viable option for all the cases? This belongs to, yeah, nice answer, Shujal. Tell me, how did you get it? Yes, perfect. Perfect, Kanishk. So, yes. So for all colors, it will be 7 factorial by 3. Tell me, how did you get it? So suppose you fix one color as blue. Perfect. Right? So you get 7 factorial. All the corresponding colors, right? If you get to be 7 factorial, if you do it as 7 factorial, then why do you need to divide by 3? Can someone tell me? Yeah, so they are equilateral. Why did you do by 3? Shujal and Kanish, can you tell me? I want to know your views. Why do you divide by 3? So 7 factorial is done. Then what is the next idea? Why do you divide by 3? So it doesn't actually fix the rotational ideas, right? Why? Can someone tell me? It is one step ahead. Yes, perfect, Kanish. Perfect. So this is the idea. So this is the idea. Suppose you color one face as, suppose you color one face, okay, like this. So to avoid the rotation stuff, suppose you color one face, okay. You fix the color face to avoid the rotations of other. So you get 7 factorial for this. But there are other rotational possibilities. What are the other rotational possibilities, guys? The other rotational possibilities are the following. Like this. Okay. So therefore it can, this is occurring thrice, essentially to get unique colors. So all these are same actually, you know. All these are same. And there exists a coloring here which is equal to exist a coloring here which is equal to exist a coloring here. Okay. So we cannot really do that. Therefore what do we do? All these are same. Therefore the whole way to divide by 3 because is equal to 1. 3 is equal to 1, so they need to divide by 3. Okay, to get all the distinct colors. Did you understand? What happened to my screen? Did you understand, guys? Hello, hello. Yeah, there are some issues of screen, so that's why the screen went black. Okay, that's why the screen. That's why the screen. Okay. So I will explain it again. So first is that 7 factorial ways of coloring. Okay. So observe that if you color it here, these two are different. These 3 are different colorings. Okay. These 3 are different in the 7 factorial. But since rotations are same, these 3 are equal. If you color in the same manner, there exists a coloring which these 3 are equal. So essentially, it's weird to divide the extra part. So for every such coloring, 2 pairs of coloring, it happens. If you want to add one color, there exists another color. Okay, so therefore 7 factorial is not the way out because these 3 are different in 7 factorial. So, but it will be less than that, the rotational stuff. Okay, so therefore you divide by 3. By 3. Now, why 3 factorials are there? Okay, not 6, by 3. It should be 3. Okay, guys. Not 3 factorial, but 3. Because for each of the colors of this 3, these are different. But actually it is same with respect to the orientation, the rotation. Okay. This is just for one color. But see, if we don't fix the one color, again forgot your name. If I don't fix the one color, okay, then it will not happen in that Anuruddha. Yeah. If we don't fix the one color, then the actual asymmetry, like we can place that one color in other boxes also, right? Other triangles also and get the same orientation, okay? So therefore, to avoid that, we are doing this. Also understood this? When you read more mathematics in your future, you will see that this is actually something called equivalent classes. Okay? And it will be easier for you to understand. Okay, we did really beautiful problems today. Good night all of you and see you in the next session. Okay? No, not 3 factorial, but 3. There is no rotation involved over here. There are no different colors involved over here. 3 orientations are involved. 3 factorial is happening if only there are 3 different colors, right? But here we are fixing one color on the other sides, the adjacent sides to that side, where we can rotate, via which we can rotate. Actually, there are, observe this very carefully, there are 4 axes of rotation, okay? There are 4 axes of symmetry. And that's why there we have done it 4 times. So 3 axes of symmetry is this one, this one, this one, and the actual one, the center one. So 4 axes of symmetry. Okay? No, the time is over, so we will do probability next time. Good night, all of you guys, and see you next day. And yeah, please keep doing problems, and bye bye. See ya. My pleasure.